Hello everyone. In this video we will learn how to plot a function in polar coordinates. Well, consider r equals to f at theta. So for different values of theta, when you fix that value, it will give you a fixed r. Consider this: the set of all points with polar coordinates. So the first coordinate, which is r, is dependent. The theta is independent. So for different values of theta, you find values for r, and you set all these points together, defines this. All these points define a curve on polar plane. We call it a polar curve. Okay, and similar to the Cartesian case, in that case x is independent and y is dependent one. What we do is to start with find table of values for some values of theta. So basically you sketch table and you plug in different values of theta in there, like, well, the first one is you can start from 0 and then pi over 6 and then pi over 4, and you plug in different values, and for each one you will get f at that angle. Yes, so these are basically telling you what are the points for you on the ray theta equal to 0, pi over 6, and so on. Then plot these points, plot the points and connect them. Remember that we are plotting them on the polar plane, and connect them, connect the points and see what you get. Okay, we will learn a little bit more in next videos, but in this video we'll just go basic as it is. So first one is r is equal to theta. Here note that for every value of theta you basically getting same value. 0 you get 2, for pi over 6 you get 2, for pi over 4 you get 2, for pi over 2 you get 2, and everything you set, it is 2. So if you try to plot these points, what you will get that for every angle here, 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 always we are going to get the same number r. And remember that r was the distance from the origin. So here 1 point, then another one, another one, another. And well, if you look at the definition of circle, this is basically definition for the circle. For any angle you go around, the distance from the origin stays the same, r equal to 2. In general, r equals a number defines a circle, or this circle here, centered at the origin with the radius a. Yes, compare this to the Cartesian coordinate. If you have y equal to 2, it's a straight line. If it is x equal to 2, it is a straight line. One is vertical, one is horizontal. But here, if you, one of r, the first coordinate equal to 2, means a circle. Let's do another one. R is equal to theta. So in this case, so you get different values of theta. So I'll put, for example, 0, then pi over 6, pi over 4, pi over 3, pi over 2, and I will continue this. But since r is equal to theta, for each one you get the same number. Pi over 6, pi over 4, pi over 3. You may say, what does pi over 6 for a number mean? Remember, pi is 3.14, so on. Yes, so it is the number. So divided by 6, you get about like 0.52, about that. So if you divide it by 4, you get something like 0.7, maybe what, 8, something like that, and so on. But when it comes to sketching these things, so for angle theta here, theta 0, r is 0, so it will choose the origin. For theta equal to pi over 6, this is this one. It's pi over 6, so it is about half, so it will be somewhere here. Yes. For pi over 4, so it is 0.7, somewhere there. Pi over 3, it's about 1 point something. And for this one, we'll go there. Pi over 2 is 1.5 something. And you, as you roll around, you get higher and higher values. So when you get, let me see, maybe I'm doing that very well here. So when you get to 3, you get somewhere here, and then these guys are something there, and then here, somewhere here. So, and then you continue this one. As you go around more, you will go further away from the origin. So this, in this case, this is going to be something like this. It's actually spiral as you go away from the circle. So from the origin, it will go around like that. So this is a spiral. Okay. And one last one, easy one. Theta is pi over 3. This is a little bit different one, but theta equal to pi over 3 means that everything is happening on the straight array, like straight ray. Yes, so theta pi over 3, somewhere here. Yes, pi over 3. And r is the variable here, which is free. So you can choose different r's on this, and it will satisfy the equation. So basically, you set all the points here on this line that will satisfy this one. By the way, we can have r negative, and that way it will go to the negative side. And this gives us a straight line with, well, if this is pi over 3, so the slope of the line is tan of pi over 3. So y to x is tan, and here you have pi over 3 for tan pi over 3 for the slope, which is, in this case, it is basically root 3 as the slope. And in general, theta equal to some angle, theta 0, is the straight line through the origin theta equal to theta 0 is a straight line through the origin with the slope tan theta 0. So if you're looking for a line with the slope 1, then this is theta equal to pi over 4. Or so this is basically y equal to x line, or something like theta equal to pi over 2. This is x equal to 0, and so on. So these are the simple cases. We will study more complicated cases in other videos.